Okay, I'm going to take you through some PIC extra revision. Here we go. Let me just start the slideshow. Okay, so what you actually need to know for the exam is, first of all, how to set up the interrupt vector address. It's always in location H04, which is the same as D04, because hexadecimal and decimal 04 is the same number. You may see it written like this. So you may see something like 04, go to whatever your interrupt service routine is. So you might see it written in three tabs as well, but it's in that location. So that's what you need to do. So that's how the interrupt knows it's happening. So when you press port B, 0, it will always jump to the location H04. Okay, so it's slightly different to a subroutine, where a subroutine will just look for the label, whatever it's called. Okay. Next page. How to set up the ports. Okay, they're called the ports, or you could call it the data direction. You need to go into bank 1. So the first instruction there, bit set file status, RP0 goes into bank 1. The reason why you need to go into bank 1 is because the data direction, tris A and tris B, are both in bank 1. So we need to set them up. You'll see that you've got 5 X's there. Port A can be up to 5 inputs or outputs. What would you press for an input? A 1, look at it as an I for input, easy. What would you do for an output? Look at it as an O for an output, yeah? So 1 for input, 0 output. You can see port B has up to 8 inputs or outputs. And then again, go back to bank 0 afterwards. So that's how you set those up. The incom register, which actually is also in bank 1, just so you know, is always bit 7 and bit 4. You need to put and make logic 1s for the incon. So for interrupts to work, it's always bit 7 and bit 4. I'll show you on a data sheet a little cheat how to not get that mark wrong. Okay, what you have to do when you're in an interrupt, you always need to do a bit clear file intcon, 1. So essentially what happens is when you have an interrupt, the intcon, 1 flag is set. If you don't clear it, when you jump back out of the interrupt, it will automatically say, hang on a sec, you're in an interrupt, and it will go back into it. So you'll never jump out of the interrupt service routine. So you always need to do a bit clear file incon, 1 somewhere within the interrupt service routine code. Dead easy. You also need to protect the contents of the working register. So if you're doing some arithmetic sums and you're using the working register to add and subtract, for example, and then suddenly you say, right, press port B, 0 for my interrupt, stop doing what you're doing. If you don't move whatever's in the working register into a file, you will lose that information. So your first instruction should always be this one here. Move working register to file temp1, or whatever you want to call it. So that's what it does. Do all your program. There's your program, blah, 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 blah. Make sure you do a bit clear file incon, 1, as I previously said. And then just before you return from interrupt enable, make sure you move the file temp1 back into the working register. Okay. Just a note, sometimes the examiner uses, instead of the working register, they put the number 0. They are the same thing, as is file is actually the number 1. So you could do something like move file temp1, W, mean move into the working register. If you said move file temp1, 1, it would move temp1 back into itself. Okay, back into the file. Okay. Here is said data sheet. You'll notice on all of here, at the top bit here, you've got your port A, your port B, your status, your incon, your working register, your file. Notice it mentions about RP0, and it mentions about RP0 down there, bit 5, yeah? So that is the page selection bit. So it even tells you that, okay? Notice the only 2 bits they talk about on the interrupt service routine is GIE and IENT input output enable. Notice they're the only 2 bits they talk about. Oh, bit 7 and bit 4. There you go. You can't do that question wrong. Notice with the mnemonics, they tell you exactly what it should do. So let me just take this one, for example. Complement file. F is the file you want to complement, and D is the destination where you want it to go. So complement file, so you could do comp file port B, comma W, for example. Invert all of port B, put the answer in the working register. So these bits are nice and important as well, tell you what's going on. Okay, so I think I've explained that one there. You'll notice on the actual chip itself, the interrupt bit is there. INT is port B, comma 0. That's the only one that you'd use for the interrupt. Why don't you pause me and see if you can work out what these things mean? Okay, well done. So you've got polling, which is the slower way of an interrupt. So something like if you were an aircon system in a building, you could use polling. It checks every so often is the temperature above a certain thing. You would not want polling for a fire alarm, and you need an interrupt. GIE is your global interrupt enable. As you know, the income registers bit 7 and bit 4. The org number's 04, bank 1. And what instructions do you return? Ret fee. Return from interrupt enable. Okay. Complete the code to set up port B as inputs and port B as outputs. Okay, so first of all, we need to go to bank 1, don't we? So we need to do a bit set file status, comma, RP0. You could put comma 5, that would work. Yep. And then we're going to move a literal into the working register. We'll set up port A first. Sorry. Let me just have a look on this one. Move from work register file, port B. Okay, so yeah, we'll sort port B out first. So port B are all inputs. So 1, 2, 3, 4, 5, 6, 7, 8. Move from work register file, tri-state TRIS-B, stands for tri-state B. And then all of port A are going to be outputs. So again, move a literal into the working register. You've already got them all there. You could put the leading zeros on, 1, 2, 3. If you just put those 5 bits, that would be absolutely fine. Move from working register to file TRIS-B, and then we want to set up the interrupts. So we know it's going to be bit 7, 6, 5, 4, 3, 2, 1, 0. So move a literal into the working register, and obviously move from working register, move from working register to file incom. And then obviously we need to make sure we bit clear file status, because this takes us back to bank 0, which is where all your main program is, all your main instructions. So you've gone to bank 1, set up port B, set up port A, set up incon, back to that. Okay, maybe you might want to try that yourself now. So you could obviously reverse this back and see if you can get that one correct yourself. What 2 instructions protect the working register when in an interrupt? Use temp1 to help. Again, I said this on the previous page. So we need to basically move the working register to a file, temp1. Do all your interrupt service routine, blah, 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 blah. And then at the end, we need to move file, temp1, back into the working register. And obviously you can return from interrupt enable. Okay. Finally, let's finish with a question on this. So we've got a bit of code here. So we've got 5-second delay, we've got buzzer, we've got a 1-second delay subroutine, which I guess is going to be called 5 times even before reading this, flow diagram, and here's all your code going on here. So let's read the first question. What is the purpose of the instructions between 124 and 129 there? Well, that sets up the data directions of port A and port B. I'm not going to write that down. Hopefully you're okay with that. So it sets up the data direction for port A and port B. In this particular case, it's making the least significant bit on port A an input and all of port B outputs. Okay. After the switch is pressed, how many times is the instruction lot 138 executed before the buzzer sounds? Explain your reasoning. Right, look, it moves the number 5 into the register called count, then it calls 1 second, and then it decreases the file, skip if 0, go to next. So most people think that will be 5 seconds, but it wouldn't actually be 4 steps. Okay, so where are we? How many times is the instruction executed? It's executed 4 times, which would give the 5-second delay. Does that make sense? Hold out your hand with 5 fingers, count 1 down, 4, count another one, 3, count another one, 2, count another one, 1, and then it will skip because it will be 0. Okay, so the answer is 4 times. And then obviously you could put something like on the fifth time it will jump over. Okay, so on 5th decrease it will jump over because it will be 0. Okay, which port and which bit is the switch connected to? So this is a switch here. Well, have a look down here and think which one logically would be an instruction with a switch. There's only one instruction down here, which is there, which is related to a switch. Port A, 0, port A, bit 0. In which line does the microprocessor check to see if the switch has been pressed? Well, that is that same switch, isn't it? 1, 3, 2. This is easy, isn't it? Before the microcontroller executes the instruction in line 137, the count register contains the number 3. Okay, so before it executes, it's got the number 3. What does it contain after it's executed? Can we do a bit of maths? What's 3 minus 1, guys? Yes. Okay, explain in detail how the processor knows when the count register contains 0. So you've got 3 marks here. So what you need to do, you need to mention it's looking for the 0 flag in the count register. When the 0 flag is a logic 1, the answer is 0 and it will jump the next instruction. So you need to put that into words. So to get your marks, you're saying about the 0 flag. You're talking about when it gets to 0, it will look for the 0 flag being set, and it will jump over that when the 0 flag has been set. They would be your 3 marks. Modify one instruction so that the buzzer sounds 10 seconds. Well, think about it. If that is 5 seconds, how would you make it so it's 10 seconds? What is a modified instruction? Move a list to the working register. What number do you think we're going to put in, guys? 2, 3. Number 10? Or was that just a bit silly? I think number 10. Yeah, let's go for 10. At which line does this occur? Okay, that was from 2025. Obviously, sometimes they give you missing bits and you've got to write the answer. Your data sheet is your friend. Literally, say what you see with your data sheet. It's all there. You should all get some really, really solid marks on this question. It's not too difficult. It's all right. It's say what you see. Go for the logical answers. Okay, cool. Thank you very much.